Okay.
All
So
right.
first, so basically, for infrared spectrum, you have like usually you observe spectrum of a fundamental. So fundamental just means it should be here. Okay. Oh wait, where is it? Okay. Did I not show it here? Well, I'll just write it again. So basically, fundamental just means it goes from v equals 0. Or v equals like, I think just v. So basically the vibrational quantum number, it increases by v of +1, and that's the fundamental.
Okay.
And when it does that, we can have two scenarios where it can have the J level can increase by one quantum number, or it can decrease in one quantum number. And that's called the R branch and the P branch separately. So R branch, you increase by one quantum number, and the P branch, you decrease by one quantum number. Now, this can happen pretty much like the same kind of way, but except you have an overtone. So overtones increase by for V for two quantum numbers. So it'll be like two higher than the previous quantum number, and that's called the first overtone. When you have a first overtone, you can still have J increase by one quantum number. So R branches and P branches can happen here too. Now, does that make any sense?
Plus or minus 2?
It's just +2. It doesn't decrease.
Oh, so for the first overtone, we only have R branch.
We have R. I mean, it's pretty much the same thing as the fundamental, but except the V is just increased by two quantum numbers. You still have an R branch and a P branch, and it's shown. Wait, you had a question before?
What?
What'd you say?
No, I was just want to, go over the problem 5.
You just want to go over it all together?
Yeah.
Okay, so pretty much the same thing is gonna go with fundamental, except I think you have like different equations, but I don't think they're really that different. So let's just say, okay, so the infrared spectrum of HCl is very dilute gas has been recorded in its region for the first overtone. The following information is available: first, third, fifth lines in the R branch, first, second, and third lines in the P branch. So, and determine a rotational B0 and B2. So what I did here is, so when they're talking about the first, third, and fifth lines, they're giving you the values of V of 0, of the V values in terms of J. Now, to determine which J level it belongs to for each line, I wrote an equation for it. So pretty much if they tell you it's the first line on the R branch, all you have to do is use N is a number line. So the first line they tell you is the first line they tell you is this, which is plugged in right here. And so I put 1 here because the first line, 1 minus 1 is 0. So this will be VR of 0 because we're talking about the R branch and the J level before is 0. Does that make sense?
So the 500, 687 is for the fundamental, or that's for the first line.
It's for the overtone. I'm talking about overtones.
Okay.
Like I said before, overtones really the only difference is that we increase by two quantum numbers. We still have R branches and P branches.
Oh, okay.
And for, I guess I'll go more in depth, but you know what V is, right?
Not really. I'm sorry.
Okay. So V is basically the difference between wait, let me write it on a separate sheet. So the V is the difference between the rotational row vibrational energy. So V, let's say we're having fundamental here, and we're having overtone, so it's V plus two, and it can be J plus or minus one minus V, minus G. And then the initial J value. So it's pretty much, you know how you calculate the rotational energy for one quantum energy for one quantum level, right?
Yeah.
So there's an equation that tells you can calculate this with V and J because an atom can both rotate and vibrate. So we have an equation like that, and then we can plug it in to find that energy. But for a spectrometer, we can find a difference between the energy states. And because of that, the lines tell you the difference between the two energy states, and that's what V of R is. V of J is. Now, when you're talking about V of R, you're talking about they're talking about the it's G. So we're talking about first overtone, so it's V plus two, and this will be J plus one because it increases by one quantum level minus G, V, and J. Does that make sense?
Yeah.
Okay, so basically, when we're talking about the R branch, R branches are usually on the right, I believe. Yeah, they're on the right, and they increase. The J level increases when you go to the right. So it'll be V of zero for the first line, V of one for the second, and so on. Now, and this would be, let me just say, this is the final state, and this is the initial state. And so V of the P branch is pretty much the same thing, but this is just the row vibrational energy at a specific level. And then this time we decrease by a quantum level for its final state, and its initial was G of Vj.
Okay.
Now, do you understand what V is?
B or V?
V.
Yeah, this is the difference. Yeah.
Yeah, it's basically like, remember how if when an electron emits a photon, something like that, you can calculate the energy difference.
Yeah.
That's what basically V is. It's like in terms of wave numbers. And you can calculate that over 8C, but you can just write it as this, which is much more simple. But yeah, so that's what we guess. So experimentally, when we're calculating the energy differences, we can determine the constants that they want you in this specific question. And in lecture they derive a bunch of stuff that you can find to find the constants, and you're using those derivation formulas to basically solve for this. So when they're saying the first, third, and fifth lines, when you're looking at the spectroscopher, he drew it itself. He pretty much just like said, okay, so this is the R branch, and this will start a transition from 0 to 1. Since V of J is just its initial condition, so that J value is initial condition, we have 0 plugged into that. And I'll show that right here. So the first line, which I put this equation here so that way you don't have to like draw it or just try to visualize it. But it's pretty much, okay, so the first line, the J value for that first line would be 0. And that'll be for the R branch. Now, does that make sense?
Yes.
Okay, so for the P branch, it's easier because it's basically saying the first line of the P branch is literally just the J value. So let's say I say the first line of the J branch, then it's just J equals to 1. And the first line of the second line will be J is equal to 2. Okay, so after finding that, you're going to use these two equations here. Now to use these two equations, we need to find, so the first equation, we need to find two J levels, two V, so we need to find a VR and a VP that have the same J's. And we found here that we were able to find those. So based on that, so we have only two right here, V of R of 2 and VP of 2. And then from subtracting these, it will equal to 2b of 2. And we need a J value here. Now, since the initial J we found is 2, we can plug in 2 for this. And then after doing that, we can solve for B2, which is from the problem. Does that make sense?
Yes, yes, that does.
Okay, so the next one, they're asking you to do a J value, but they want you to also do for a VP, initial J value that's 2 higher than that like VR level. So we found out that we can use V of R of 0, and then we use VP of 2 because it's 2 higher than that V of R. And then from that, you can just plug in and equal to 2b of 0. Now remember that the J value we use would be the one that's 2 lower, so it would be 0. And then after that, we calculate b of 0. Does that make sense?
Yes, yes, that does.
Okay. So then the next part, we have to calculate BV. Wait, like alpha E, I think, right? Yeah. So we have so it's weird. I didn't know how to do this initially when I was solving this for your review, but I figured it's actually really simple. So B of 2 and B of 0 relate to B of V, because this is when V is equal to 2, and this is when V is equal to 0. And if we're talking fundamental, we'll have B0 and B1. Now that's because the highest that V can be in fundamental is 1, and the lowest can be in fundamental and overtone is 0. So based on that, we can plug in basically what we found initial. So we found B of 0 and we found B of 2. So B of 0, you can use this equation here. Since V is equal to 0, then that means we can plug in 0 here for the V. And then we can find what A of E is, but we have a linear set of equations here. We can have another equation here, B of 2, and then we'll have BE minus AE, and then we'll plug in the 2 here because this is B of 2. And then we can, what I pretty much did was I added these, but I made this into a negative, so this will cross out. And then we'll have what A of E is equal to. And then once we got the AE solution, we can then plug into the original equation and solve for B of E. Now, that makes sense for this process?
Yes.
Okay. The last part, I don't want to go too much in depth. I don't know what he specifically did with this. He should have just told you to calculate RV, but pretty much you just have to calculate how you calculate B in like your recitation problem, stuff like that. And just because it's in the center, because your measurements are in wave numbers, you're gonna have to convert them into energy. So to convert them into energy, he's showing this right here, where you have to, where did I put? Yeah, you have to use HC because you have your answer in wave numbers. Now, you'll know it's in wave numbers when it's in like centimeters, or it's centimeters to -1, or meters to -1, or something like that. And you can use HC over here. And those have to be in CSE units, I think. Yeah, CSE units. And then once that's like ergs per second, which are CGI units. And you have to calculate the reduced mass. So what you do is you calculate, to calculate reduced mass, pretty much just calculate AMU and then just convert it into, why did he convert it into kilograms? Oh yeah, he did keep it, put it back into grams, but you should just let it in grams. But you convert your reduced mass into grams because that's CGI units, and then you put this in ergs per second. And what I suggest for that is to ask professor specifically what that value is in ergs per second, and I think he's going to give it to you like at the end of the test. And then over 2 times the reduced match, which you calculated over here, then times BE, which is BE, which you calculated over here. Let's be, yeah, it's calculated somewhere. Okay, yeah, it's right there. Like, okay, there we go. Okay, so after calculating BE, wait, why didn't he
Again,
like, yeah, um, let me just see if he cancels out terms correctly, because okay, n times 8c meters. Did you calculate that? Because okay, so he actually plugged in B, then he divided by 8c. Oh wait, oh I think I know what. Okay, so he actually he multiplied by 8c because BE is here, so that's what he did. And okay, that makes sense. Which is Planck's constant, the speed of light, because it's in centimeters because that's CGI units, and it's in ergs because CGI units. And after solving that, you get your answer below. Does that
okay.
that make sense?
Yeah, that makes sense. Yes, thank you.
Okay, no problem. I would suggest if he gives you something like this, um, then just ask the units for each one and then just convert it. I don't think he's gonna ask something like this. It's weird that he asked you something like this, but he never gave this on our old exam because it would be like too long. He just gave us hard problems, but at least if you figure it out, you can solve it in the right amount of time. But yeah. How many problems did he give you for the exam? Like 6?
7.
7?
Or 7 for this year, I mean.
7 for this year. That's kind of ridiculous. And it's like an hour and 20 minutes, right?
Yeah.
Okay.
Wait,
Ew.
is it? I think it's 75 minutes. Or, I don't know.
Oh, good luck with that then. I would say with this, with anything like that, when you have it in a form where you can calculate it, if you know what to do, I would suggest calculate it in your head for like 5 seconds. It take you longer than 5 seconds to calculate in your head than just like use your calculator and just run through it. So for stuff like commentators and stuff, I would do that and I would like go fast with it, do the product rule and do the subtraction in your head, and pretty much just like that's my suggestion for this problem. And then if you have like enough time, check over your problems. Yeah.
Yeah. Thank you.
No problem. You have any other questions?
That's it for now.
All right. Stop sharing my screen then. Oh, we got someone else. We got Tracy. Tracy, you got any questions? Guessing she.
It was going about going over some of the questions that you went over in your video. Right now I'm still going through it, but what some of the things I'm having a problem understanding is in the exam 1, problem 2. There's some math I'm getting confused by.
Yeah. That's not it. Closer. Is it the eigenvalue problem? I'm guessing.
It was the
Oh.
particle and a mass.
Oh yeah, in a two-dimensional box, right?
Yeah, this one.
All right.
So it's the part during the calculation of the ratio when we plugged after we plugged in the number and crossed out the constants. For the like the bottom part of the ratio where it's like 1/4 angstrom squared plus 1/16 angstrom squared, why is
Yeah,
it become 17/16?
because when you multiply by when you do like least GC whatever it is for adding fractions, you have to multiply by, oh wait, I see what you mean. Why did I put 17/4, 16? And then I solved it. Oh wait.
And
Oh,
another thing is that I'm confused when I was going because I was comparing it to the professor's answers, and the professor crossed out, like took out the LX squared and added as a constant and crossed
oh,
them both out. So it's just LY squared. That was the only value
okay.
he used.
So he did it a different way, which if you get the numbers ready, that one's just doing it like that. So what I did for this, I think I did it for me. Let's see. So it's like 4 squared, 4 squared. That's 4/16, and that's plus 1/16. That's like 5/16. Yeah, okay. I think I know what I did wrong. It's 5/16, and I put it here, but I forgot to change it. So yeah, and when he gives you numbers, don't do what I don't know why he did it like that, because you only do that when he's telling you, oh, what's the ratio for LX or LY or something like that. And so if you're given numbers, then just don't even bother and just use the equation. But if he tells you like, oh, put it in terms of LX or LY or something like that, then just do what he did. But, yeah.
Okay. Wait, I'm so confused because like obviously multiplying the 5/4 by 5/16 still wouldn't get like 4. So still I don't know. I'm still a little lost on that calculation. I don't know.
Because it's 5 when you add this, it's 4/4 plus 1/4. So you're gonna get 5/4, and that's gonna be 5/16. And when you divide by a fraction, you just multiply by the reciprocal. So you're gonna have 5/4 times 16 over
Okay,
5.
I
Yeah.
see it. I get it now. Okay.
Okay. You have any other
Yep.
questions?
Okay. So the other question was, it was on 5 of exam 1.
Yeah.
So it's regarding when we're plugging in like the negative infinity and the 0. For the first like what's it called? The first part where it was the d squared e to the negative 2kx over
Yeah.
yeah, that one. Um because it was an e, I'm confused because you said because infinity was a negative that it goes to 0.
Oh, I said that in that yeah, because when you plug in infinity here, it's negative 2k times infinity, but you're basically gonna have negative infinity
Okay,
because
so it turns
basically anything,
negative.
yeah, yeah,
Then when it is negative infinity and says that it goes to 0, why does e itself just become 0 and like the whole thing becomes 0?
because when you really think about it, when you raise when you're going, anytime you go have a negative like e to the negative something, then it's gonna like go towards 0. So if you look at like a graph or something like that, and you have like e, right? I think
Yeah.
e start from 1, then it's gonna go like this. It's gonna go down and down. But because it's e, it never crosses 0. It will always approach 0. So it's pretty much when you e to the negative infinity is pretty much equal to the limit as it approaches infinity. It will always try to approach 0. So it's gonna be like so small that's gonna equal 0.
Okay, so, but when it's actually just equal to 0, the E becomes 1 because when it's
yeah. Mhm.
Okay, I guess that makes sense. I didn't get too far, so I don't have too much questions right now. It's just some burning questions I had.
Okay,
Thank you.
no problem. If it comes to reading it and you see a math mistake in my notes, just go to the professor's thing and see what he says.
All right.
But you're all good? No more questions?
Yeah, for now.
Okay, good. Let me say that again.
It's the practice exam for exam 3. I think it's spring 2020.
I don't think I have that. Can you pull it up on your screen?
Oh, yeah, okay, I just print that out, but I can't open it right now.
See it.
Okay,
Ooh, yeah.
so yeah, it's for this question.
Mm-hmm. The time of quarter X one normal line for one year, two diagonal. They form diagonal line manipulation. And approach molecular. Where the real values? Real value, yeah, okay. So, determine the orbital energies, write the results of part B, make these representation for energies. Oh, this is like they basically tell you what to write. So let me try to, I think I did this one before. Actually, no, I didn't. Let me take a screenshot. Oh wait, I'm gonna take a screenshot of this, but wait, I think I can probably take a quick picture of it on me on a telephone. Did not send that one. Okay, so so it's pretty much like a couple problem, except you don't have a molecule. They just tell you what to do. So I'll share my screen. Oh, stop sharing your screen for a second.
Okay.
Okay, let me share my screen.